Dear students of the General Secondary Certificate, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to your program Madrasa ala al-Hawa. Don't forget to get your copybook, your pen. Let's first welcome to your guest and my guest, Mr. Muhammad Abdullah Riyad. Welcome back, Mr. Muhammad.
Welcome.
Today, inshallah, we'll continue our discussion about alcohols and phenols. Okay?
Yes. Okay.
Actually, I'm waiting for your revision. It's very important to our students.
Yes, okay.
Okay. Let's start with, continue our discussion about alcohols.
Okay. The last reactions, the reaction between ethanol and sulfuric acid. With sulfuric acid. Reaction with sulfuric acid. This reaction depends on the temperature because the product of the reaction differ according to the degree of the temperature. When the ethanol reacts with sulfuric acid at 80 degrees Celsius, C2H5OH plus sulfuric acid H2SO4 at 80 degrees Celsius, it gives C2H5HSO4 plus water evolved. It gives the ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Sulfate. This is the reaction when the temperature equals 80 degrees Celsius. But what's about the reaction between ethyl alcohol with sulfuric acid at 140 degrees Celsius? 2 moles of ethanol to C2H5OH, sulfuric acid, dehydrating agent. It takes 1 molecule of water from 2 molecules of ethanol at the temperature 140 degrees Celsius. C2H5OH ethanol when react with sulfuric acid at 140, sulfuric acid takes 1 molecule of water H2O from 2 molecules of alcohol, and the alcohol is converted into C2H5O, C2H5 diethyl ether, diethyl ether, diethyl ether. We know that the ether has the general formula ROR, but this compound is diethyl ether. So when the temperature is 80 degrees Celsius, it gives the ethyl hydrogen sulfate. When the temperature becomes 140, it gives diethyl ethers. But when the temperature reaches to 180, the sulfuric acid can remove 1 molecule of water from 1 molecule of ethanol, C2H5OH, H2SO4, 180 degrees Celsius, it gives C2H4 plus water. It gives ethylene plus water or ethene plus water. So the reaction between alcohol and sulfuric acid independent on the temperature. Why? Because it gives different products according to the different temperature. Now let's take the dihydric alcohol, trihydric alcohol, and the polyhydric alcohol. We classified monohydric alcohols to primary, secondary, tertiary, and we explain this. And now we will take the dihydric alcohol, the alcohol which contains 2 hydroxyl group, and the trihydric alcohol which contains 3 hydroxyl group. The alcohol which contains more than 3 is called polyhydric alcohol, such as sorbitol and glucose or fructose. Let's explain the ethylene glycol, which is dihydric alcohol. Dihydric alcohol. Example, CH2OH, CH2OH. It has two OH, two hydroxyl group. This is called ethylene glycol. Ethylene glycol. How to prepare ethylene glycol? What is the physical and chemical properties of ethylene glycol? What is the uses of ethylene glycol? When we explain the properties of ethene, we explain the oxidation, or what's called the Peyer's reaction. We say that oxidation of ethene, it gives ethylene glycol. So preparation of ethylene glycol, preparation, oxidation of ethene, C2H4 plus oxygen plus water in presence of KMNO4 in alkaline medium. Alkaline medium. Why? To increase the concentration of hydroxyl group. It gives CH2OH, CH2OH, ethylene glycol. So oxidation of ethene gives the ethylene glycol in the presence of KMNO4 and in alkaline medium. It is called Peyer's reaction, and we explain this reaction as a method to detect the presence of double bond or to differentiate between unsaturated and saturated. Also, we can make oxidation by using hydrogen peroxide. It is so easy. C2H4 plus H2O2, hydrogen peroxide. It gives ethylene glycol. CH2OH, CH2OH. This is a simple method to get ethylene glycol. This is about the preparation of ethylene glycol from C2H4. Sometimes he asked me how to convert monohydric alcohol, ethanol, to dihydric alcohol, ethylene glycol. We know that we can get ethene from ethanol by using sulfuric acid, and the degree temperature equals 180, as we explained now. Then we convert, when we convert C2H4 into C2H5OH into C2H4, then we oxidize C2H4 by using Peyer or by using H2O2 to convert monohydric alcohol to dihydric alcohol. The properties of ethylene glycol. The physical properties, ethylene glycol is a liquid, transparent, viscous, dissolved in water, has high boiling points, more than 190 degrees Celsius. This is why the presence of OH, take care, presence of OH can make a hydrogen bond. So presence of 2 OH in ethylene glycol makes hydrogen bond between water and ethylene glycol, so ethylene glycol dissolve in water. And OH in ethylene glycol makes hydrogen bond between molecules of ethylene glycol and prevent formation of hydrogen bond between molecules of water. So it prevents formation of ice of the water or crystals of water. So we use ethylene glycol as antifreeze substance. Sometimes they ask me about give reason ethylene glycol is used as antifreeze substance. The answer will be the presence of OH makes a hydrogen bond between water molecules and ethylene molecules, and this prevents water to form crystal of ice, so it is used as antifreeze substance. Also, presence of OH increase the boiling point of ethylene glycol because it makes hydrogen bond between molecules of ethylene glycol. Also, ethylene glycol can be used in hydraulic brake, can be used in printing ink and ball pen ink. Also, we convert ethylene glycol into polymers, which is called polyethylene glycol. Polyethylene glycol. This is used in making dacron. Also, it is used in making cassette, the tape of the substance which on the cassette, tape of cassette and photographic films. Also, the substance, this is made of PEG or polyethylene glycol. This is about the properties and the uses of ethylene glycol. What's about the trihydric alcohol?
Sorry, before transferring to the trihydric alcohol.
Yes.
Sorry. If we have a question of using the ethylene glycol as an oil for the hydraulic brakes,
Yes.
we said because of its high viscosity, as you
Yes.
said before.
Yes.
Okay, so I give reason ethylene glycol used in hydraulic brakes because of its high viscosity.
Okay.
Thank you.
High viscosity. Let us to use ethylene glycol in hydraulic brake, also in making printing ink and the film. This is because the viscosity
of
the
its
ethylene
viscosity,
glycol.
as you mentioned before. Thank you. Sorry for interruption.
Now let's take about how to explain trihydric alcohols. Trihydric alcohols. Alcohol which contains 3 hydroxyl group, CH2OH, CHOH, CH2OH. It is called glycerol. Glycerol, it is a trihydric alcohol. We can prepare glycerol when we react the oil with sodium hydroxide or potassium hydroxide in preparation of soap. It gives glycerol and soap. Glycerol, because it contains 3 hydroxyl group, it causes increase the boiling point. The boiling point of glycerol, which equal to 290, more than boiling point of ethylene glycol, which is more than boiling point of ethanol. But when the OH increase, the solubility in water increase and boiling point increase. So glycerol dissolved in water. It is a liquid, transparent, viscous, has good taste. It is used in making creams to make the skin soft. Also, it is used to make the textile tolerant and soft. Also, we can use glycerol to prepare explosive when it reacts with nitric acid. Trinitroglycerol, it is used in weeding arteries and also as explosive. Let us to say the reaction between glycerol and nitric acid. CH2OH, CHOH, CH2OH. Glycerol with 3 molecules of HNO3 nitric acid in presence of concentrated H2SO4 to absorb water and prevent formation of reversible reaction. It gives 3 molecules of water plus CH2O NO2, CHO NO2, CH2O NO2. Trinitroglycerine, trinitroglycerine or TNG. Due to the presence of NO2, it is used as explosive. We said before, we said that presence of NO2 makes this compound, the compound of a nitrate compound, make this compound, it is used as explosive due to, number one, it has its fare, which is carbon. It has its oxidizing agent, oxygen. The weak bond between the N and O is broken to form a strong bond between the N and N and C and O, because this compounds, when burning, it gives nitrogen, carbon dioxide, water vapor, and other substances. So it is used as explosive. Also, it can be used in within arteries. So it is used in heart crisis. This is about the trihydric alcohol. Polyhydric alcohol, which contains more than 3 hydroxyl group. Polyhydric alcohols. Sorbitol, number 1, CH2OH, CHOH, repeated 4 times, CH2OH. This is called sorbitol. Also liquid, dissolved in water, sweet test, whatever the properties of alcohols. This is a polyhydric because it contains more than 3 hydroxyl group. Also we have glucose and fructose. We know that the molecular formula of glucose and fructose, C6H12O6. So glucose and fructose are polymers. Why? Because they have the same molecular formula, C6H12O6, but they are different in structure formula. They are different in structure formula because glucose contains, this is glucose, CHOH 4 times CH2OH. Besides the hydroxyl group, it contains CHO formyl group aldehyde. So we can consider the glucose is aldehydic compound. So it is called aldohexose. Aldo due to the presence of aldehydic group. Hex because it contains 6 carbon. Ose, sugar, the suffix of sugar, ose, glucose, fructose, sucrose, rhamnose, whatever. So glucose C6H12, the structure formula CHO, CHOH all by 4, CH2OH. It contains formyl group CHO and hydroxyl group, so it is aldohexose or aldo compound. Fructose, which also has the formula C6H12O6, but the structure formula CH2OH, C double bond O, CHOH all by 3, CH2OH. Besides the hydroxyl group, it contains carbonyl group, which represents ketone. So it is called ketohexose. Keto due to the presence of CO group. This is the fructose. Also fructose and glucose, they have the same molecular formula, so they are isomers. They are isomers. Now let's explain phenol. Phenol, this is aromatic hydroxyl compounds. Aromatic due to the presence of benzene ring. Phenols, presence of benzene ring and hydroxyl group on benzene ring. C6H5OH. This is called phenol. When the benzene ring contains 2 hydroxyl group, OH, it is called catechol. Catechol. Catechol is dihydroxybenzene. 1 and 2 dihydroxybenzene. When the benzene ring carries 3 hydroxyl group, it is called pyrogalol. OH, pyrogalol. Pyrogalol is a 1,2,3 trihydroxybenzene.
May we return to the previous paper, please? I need to mention something to our students.
Yes.
Dear students, look to the previous paper on the data show. Here we have catechol. It has two hydroxyl groups, right? And the word catechol has got two C. So when in the exam I asked you how to draw catechol, remember that the word catechol contains two C, so it has two hydroxyl group. While pyrogallol has 3L, so it has three hydroxyl group, because most of our students get confused between catechol and pyrogallol. Pyrogallol has got 3L, so it has 3 OH. Catechol has got two C's, so it has 2 OH. Okay? Thank you. Sorry for interrupting.
To remember okay,
how
okay.
to draw it, because it's some sort of confusion for our student. Thank you, dear student.
Sometimes we need some points to let the student remember the structure formula.
Maybe by a drawing or a hint or something in the word like this, because our syllabus is a rich one.
Okay.
So sorry for interruption, but I need to help our students to remember these drawings.
You're welcome.
Thank you.
Let's to explain preparation and properties of phenol. Hydroxybenzene or phenol. We can prepare phenol by two methods. Number one, from coal tar. We say that we can get benzene also from coal tar when we convert coal into many compounds by destructive distillation. It gives liquids, gases, and solids. And from these liquids, coal tar, we can make fraction distillation to get benzene and also to get phenol. Number two, from halobenzene, such as chlorobenzene, fluorobenzene, chlorobenzene, iodobenzene. Here's the reaction when we get chlorobenzene C6H5Cl. We need to remove halogen, chlorine, from the benzene ring, and we want to add it OH. We know that benzene ring is electrophilic. It can attract negative ion. So the negative chloride is make strong bond between benzene and the halogen. In order to break this bond, so we use 3 points here, is very important. Number one, we use a strong alkali such as sodium hydroxide or potassium hydroxide. This is number one. Number two, we use high temperature, 300 degrees Celsius. Also we use high pressure, 300 atmospheric pressure. Take care in order to remove halogen atom from benzene ring, because it is a strong bond between the benzene ring and the halogen, because the benzene ring attracts negative. It is electrophilic compound. So we use strong alkalis such as sodium or potassium hydroxide, high temperature 300 degrees Celsius and high pressure 300 atmospheric pressure. It gives sodium chloride NaCl. So sodium takes halogen and OH can replaces halogen or chlorine to form phenol. OH, C6H5OH. So take care to prepare phenol from halide, from halogen halide benzene. We use strong alkali, sodium hydroxide or potassium hydroxide, 300 degrees Celsius, 300 atmospheric pressure to form NaCl and phenol. This is how to prepare phenol. Let's to make a comparison between phenol and alcohol. Here, alcohol and phenol. We know that the general formula of alcohol ROH. Let's to write the symbol of alcohol like this. While alphenol AR, aryl group OH. I said that benzene ring electrophilic. It attracts the negative to form a negative partial charge on benzene ring. Make that positive partial charge on oxygen. The hydrogen carries positive partial, so the repulsion occurs between oxygen and the hydrogen and phenol. So the presence of benzene ring makes the bond between the O and H long and weak, can be broken easily. While in the case of alcohol, alkyl group repel electrons, forming positive charge on the alkyl and the negative partial charge on oxygen, which attracted more to hydrogen, which carries positive partial. So the presence of alkyl group makes the bond between the O and H short and strong. Short and strong. So difficult to be broken, but the bond between the alkyl and the oxygen can be broken. So phenol react as acid because it can easily lose the hydrogen. So we call the phenol carbolic acid. It is called carbolic acid. Carbolic acid. While alcohol is neutral, because it is difficult to separate the O, we say that the acidity properties of alcohol appears only in the reaction between strong metal such as sodium and potassium. As we said, it gives alkoxide. So again, we'll explain the difference between, when ask me about the acidity of alcohol and acidity of phenol, I must say that presence of alkyl group makes the bond between the O and H short and strong, so it is a neutral compound. While the presence of benzene ring and phenol makes the bond between the O and H very long, the O and H, because repulsion occurs between them, very long and easy to be broken, so it has acidic effect. We call the phenol carbolic acid. Both can react with sodium. Ethanol, for example, react with sodium to form sodium ethoxide and the hydrogen involved. With sodium or potassium only, the reaction between alcohols and this active metal. While phenol can react with sodium or sodium hydroxide or sodium oxide, metal or metal oxide or metal hydroxide, to form phenoxide, sodium phenoxide, and the hydrogen involved when it reacts with sodium. Sodium and the phenol, it gives sodium phenoxide or sodium phenate when we consider the phenol as an acid, and the hydrogen involved. Also, when it reacts with sodium oxide or sodium hydroxide, it gives also sodium phenoxide and water. So phenol is acid. While the reaction between HCl, hydrogen halide, and phenol cannot be occurs because the two are acids. But we know that ethanol can react with HCl to form ethyl chloride and water, while phenol cannot react with HCl or HBr. This is the difference between the alcohol and the phenol. They have some properties due to the presence of hydroxyl group, but they have different properties due to the presence of benzene ring. Here the aryl group in phenol and alkyl group in alcohols. Phenol is a solid substance, slightly soluble in water. It can dissolve completely in water at 65 degrees Celsius. It melts at 430 degrees Celsius. It has a special odor. It can be used in making aspirin, in making some drugs, in making polymers, and making plastic, and we will explain the properties of phenol with some substance such as formaldehyde or such as nitric acid to form explosives. This is about the some properties, some physical properties of phenol and the comparison between phenol and alcohol. Let's to take the reaction between phenol and nitric acid. Phenol C6H5OH phenol plus 3HNO3 in presence of H2SO4, going by the ratio 1 to 1. It gives 3 molecules of water. And we know that the presence of hydroxyl group in benzene ring shift the compound to the ortho and para position. So the presence of OH shift the nitro group to ortho, NO2, NO2, NO2. Take care, N is attached to benzene ring, NO2. This compound is called 2,4,6-trinitrophenol, TNB, TNB. Also it is called bicric acid. Bicric acid. It is called bicric acid. Due to the presence of nitrate group, it is used as explosive. It is used as explosives. Also, we can use the bicric acid in treatment of burns. This is why, because bicric acid forming yellow layer covers the skin cannot be removed until the skin eroded, until the skin renew. So it keeps the burn, and it is used in treatment of burn. This is about the TNB or bicric acid. Here take care the reaction between acid, carbolic acid, with acid, nitric acid, in presence of acid, H2SO4, to form acid, bicric acid. This is a good reaction. Acid react with acid in presence of acid to form acids. And bicric acid, it is used in explosive and in treatment of burns. And we said why? Because it forms a yellow layer, covers the skin, cannot be removed still for a long time until the skin renew or erode. Let's take the reaction between phenol and formaldehyde. Formaldehyde, HCHO. This is a phenol, OH on benzene ring, OH. We know that formaldehyde, HCHO, HC double bond OH, or HCHO, not OH. Why? Because the OH refers to the alcohol, hydroxyl group. But this is called formaldehyde, methanol, plus phenol, another molecule of phenol. The reaction occurs between the formaldehyde and phenol when hydrogen from phenol and hydrogen from the second molecule takes oxygen to remove the water. So the water comes from oxygen of the formaldehyde and 2 hydrogen from the phenol. And then the bond occurs between the phenol and formaldehyde, like this, CH2, here OH, OH. It is a copolymer compound, copolymer. Copolymer is the building unit to form polymers. show the reaction between formaldehyde and the phenol to remove water. It is called condensation polymerization. Why? Because two different molecules combine together to form a polymer, copolymer, and the small molecules, water, is released. The copolymer can be condensation, occurs once more with CH2 and phenol, and here CH2 and the phenol. This is the condensation continue until it gives polymer, but this is called condensation polymerization to form bakelite. What's called bakelite? Bakelite, it is a thermosetting substance. It reacts the effect of heat, the effect of electricity, so we can use it as electric insulator, also in ashtrays, because it resists the effect of electricity and the effect of heat. This is about the condensation. Condensation, we said that, between phenol and formaldehyde. Condensation, two different molecules combine together to form a polymer, and the small molecules such as water released. How can we detect the presence of phenol? Phenol, when we add solution of FeCl3, phenol plus FeCl3 aqueous, it gives violet color. Violet color. This is important to differentiate between phenol and other compounds. When we make a differentiation between ethanol and the phenol, we are adding solution of FeCl3. It gives violet color with phenol, but doesn't give the same color with ethanol. When we want to differentiate between phenol and acid, acetic acid or benzoic acid, we adding FeCl3. It gives the violet color with phenol, but it doesn't give this color with acids, acetic acid or benzoic acid. So it is a very important point to detect or to differentiate between phenol and other substance. Let's take the acids.
Actually, now we finished the alcohols and phenols. Now we can transfer to the carboxylic acid.
Yes.
These are the most acidic compounds in the organic chemistry. Before starting, let's arrange the organic or the organic compound generally, comparing to the mineral acids according to acidity, starting from alcohol, passing to the phenols, then carboxylic acids, aliphatic and aromatic, then to the mineral acids. Let's start with this introduction.
Okay.
How to compare the acidity of these compounds with each other.
Okay. Arrangement some compounds according to acidity. Inorganic acid is the strongest one. Inorganic. Such as hydrochloric acid, sulfuric acid, nitric acid. Inorganic acids stronger than organic acids. And organic acids can be arranged as aromatic acid, such as benzoic acid, stronger than aliphatic acid. We say that the presence of benzene ring makes the bond between an O and H long can be broken easily. So benzoic acid more acidity than acetic acid. Then carbolic acid. Carbolic acid, which is phenol, it is the less acidity than acetic acid. At the end, when we explain about when we put ethanol, ethanol has acidity only with the strong metal or the active metal, sodium and potassium. So we can write ethanol at the end of this arrangement. So if we take some compounds, for example, HCl, more acidity than C6H5COOH, benzoic acid. more acidity than acetic acid CH3COOH, more than phenol C6H5OH, which is more acidity than ethanol or alcohol. This is about the arrangement. If we take the carbonic acid more acidity than phenol but less than acetic acid, more than phenol but less than acetic acid, whatever. So phenol cannot react with carbonate or bicarbonate. Let's to explain what's meant by carboxylic acids and the classification of carboxylic acids. Carboxylic acid, it is an organic compound which contain carboxylic group. Carboxylic acids, organic acid have, according to the acids, have carboxylic group COOH. This carboxylic group C double bond O OH, it has two function group, hydroxyl group, carbonyl group. Hydroxyl group refers to the alcohols and carbonyl group refers to the ketone. But the presence of two groups together cancels the effect of alcohols or the effect of ketones. So carboxylic acid has a different properties. These properties according to the presence of all these atoms, which is called carboxylic group. So the compounds, organic compound which contains carboxylic group is called carboxylic acids. We want to classify the carboxylic acids according to the type of the chain or cyclic, or according to the number of carboxylic group. We know that we have aliphatic acids. Aliphatic acids are COOH or HCOOH. The first one is a formic acid. But this is aliphatic acids. We will explain some acids and how to give their names. And aromatic acids which contains benzene ring C6H5COOH, benzoic acid on benzene ring C double bond O OH or COOH. This is called benzoic acid. This is aromatic. Benzoic acid. This is classification of acids according to the chain or according to the molecules. The second classification according to the number of carboxylic group. Number one, which contains one carboxylic group, is called monobasic acid. Monobasic acid contains one hydroxyl group, COOH, one hydroxyl group. Dibasic acids contain, these acids contain two COOH hydroxyl group, and there are more than dihydric, trihydric, and whatever. Let's take examples for mono and another example for dibasic acids. Monocarboxylic acids or monobasic acids such as CH3COOH acetic acid, or C6H5COOH benzoic acid. What's about dibasic acid? Dibasic dibasic acids. COOH, COOH. This is called oxalic acid. Oxalic acid. It contains two hydroxyl group. Sometimes ask me about give example on acid contains the same number of carboxylic equals the same number of carbon. This is example oxalic acid or formic acid. Formic acid contains one carbon and one carboxylic group. Oxalic acids. Another one, phenolic acid on benzene ring, COOH, COOH, phenolic acid. All the two hydroxyl group on para position, we called it terphenolic acid. Terphenolic acid. This is about the classification of acids. We said that monobasic, basic because this part which can be replaced by a base, by metal. So it is called the basicity of the acid or the number of carboxylic group. Also in inorganic acids, we classify an inorganic acid into monobasic such as HCl, HNO3, which gives one salt, and dibasic such as H2SO4 or H2CO3, it gives two salts, or tribasic such as orthophosphoric or phosphoric acid H3BO4. So this is called the basic of the acid or basicity of the acids. Let's explain how to give a name for acids. There are two types of nomenclature. The name according to the source, it is a common name, and the name according to the number of carbon or an EUPAC system. For example, when we called HCOOH, we get this from formica and. The first time we prepare this acid comes from the study of the remains of formica and. So it is called in common name formic acid. Formic acid. According to the EUPAC, this is a common name. According to the EUPAC, we take the name of the acid, we give the acid name according to the corresponding alkane, the alkane which contains the same number of carbon, and replaces the E by the OIC. OIC. This is compound contains one carbon. The alkane which contains one carbon is called methane. Methane. We replace the E by OIC. So it is called methanoic. Methanoic is the EUPAC name, why it is called formic acid. Another one, CH3, COOH. We give it, we prepare it from acetum, so it is called acetic acid. Acetic acid. This is a common name. According to EUPAC, the corresponding alkane which contains two carbon atoms is called ethane. So in EUPAC we called it ethanoic. Ethanoic. Another one, C3, H7COOH. We get it from butter, so it is called in common name butyric acid. Butyric acid. According to EUPAC, it is so easy. The alkane which contains 4, take care this 3 carbon, and we calculate the carbon of the carboxylic group. This is a 4. 4 is called butane. It is called butanoic acid. Butanoic acid. Butanoic acid C3H7COOH. Another example. Let's take a long one, C15H31COOH. we get it from palm tree. So it is called by common name palmitic acid. Palmitic acid. According to EUPAC, the alkane which contains 16 carbon, we know that we take until 10 carbon. But here it is so easy. 16 means hexadecan. The alkane which contains 16 is called hexadecan. We replace the E by OIC, so it is called hexadecanoic. Decanoic. Hexadecanoic, it is a palmitic acid. This is about the nomenclature of carboxylic acids. Let's explain how to prepare and the properties of acetic acid and then benzoic acid. Acetic acid CH3, COOH, or ethanoic. In order to get acid, we can oxidize aldehyde or alcohol. Take care this knowledge. By oxidation of aldehyde, oxidation, it gives the acid by one atom of oxygen. When we make oxidize of alcohol, it takes two steps. Alcohols, O2, it gives acid plus water. In order to get acetic acid, formic acid, benzoic acid, whatever type of acid. When we make oxidize of aldehyde, it gives acid only. When we make oxidize of alcohol, it gives acid and water, but we use two atoms of oxygen. Let's to see how to prepare acetic acid by one of these methods. Acetic acid, when we get ethanol, C2H5OH by O2 in presence of vinegar bacteria, I said it gives water and acetic acid, CH3COOH. This is called biological method because we use vinegar bacteria. This is called biological methods to prepare acid. The second one, C2H2, by adding water, catalytic hydration, we take this equation in presence of HgSO4, H2SO4, concentration of acid 40%, the temperature 60. It gives aldehyde, acetaldehyde, CH3CHO. By oxidation of acetaldehyde in presence of KMnO4 acidified, it gives acetic acid, CH3COOH. This is the method of prepare acid.
Thank you, Mr. Muhammad, for being with us. Dear students, thank you for being with us. We'll wait for you for the next session. Assalamu alaikum wa rahmatullahi wa barakatuh.